All right, let's go ahead and get started. Hi, everybody. Hi. Last times, let's do a quick review of what we talked about in the past. Hang on a sec. Let's do a quick review of what we talked about in the past. Can you still hear me in the back? Everybody raise their hands. All right, thank you. The back doesn't just want to do things by themselves. We all have to pitch in. So, last times we talked about a number of different things that are important. So let's go over them. Algorithm. What is an algorithm? I'll go back. What's an algorithm? A series of steps you do, an ordered series of steps you do to fulfill some task. What is a program? Yes, is correct. It is an algorithm expressed in a form that a computer can execute and that humans can understand. What is a computer? It is not a rectangle. That was a lie. The computer actually is a rectangle with some things inside of it. CPU, RAM, and disk. CPU does the math. RAM holds the data. RAM looks like this. It's a bunch of boxes, each of which is the size of a word, numbered essentially from 0 to whatever the biggest number we need to hold all the memory. Okay? Important stuff. When we talk about an algorithm, when we talk about a program in C++, how do we start? What's the start version of C++? Yes? Uh-huh. And int main, open close parentheses, curly bracket. That is start. What is stop? Yeah. Perfect. Here, I'm going to throw some candy back there. Guys, I eat this stuff if I don't give it to you. Plus, it's fun for me to throw it around the room. One day I'm going to bring donuts, just you see. All right. So this is stop, return 0, closing curly bracket. All right. We can now make a program that does what? Which does very little, nothing useful, right? But it does something, it does nothing. Then we talked about variable declaration. And the idea behind variable declaration is if we were going to have input, if we're going to be doing calculations, we have to work on a number that's stored in RAM. So we have to declare our variables. In this program, we declared two variables, one named input, one named remainder. They are both int. INT in the front means int. It is an integer, a number without a decimal portion, solid whole number. We have to tell the computer how we are using the memory. That's what the variable declaration is. And what it does is it tells the computer to choose a spot in RAM to store a value. We have to specify the name of the variable, and we'll talk about today what the names can be, probably, if we get to it. I hope so. You have to specify a type, which means you have a whole bunch of ones and zeros, but what do those ones and zeros mean? They can be a number of different types. And if you want to put an initial value in that box, you use the equal sign to assign that box equal to some value. Okay? So it ends up looking like this. When we say int input equals 0, int remainder equals 0, find two boxes in memory. There's a type, it has a name associated, and there is a value in that box. And just briefly, someone asked me, what happens if you don't assign the value? What's in the box if you don't assign the value? You don't know, right? It could be anything. Odds are, probably, maybe it'll be 0, maybe, but it could be anything, and you have no idea what it will be. Okay? So it's a good idea to always make sure you assign things. Okay. So let's talk about types in a little bit more detail. Why do we have to define a type? And the answer, as I already kind of referred to, is that everything in the computer is really just a bunch of ones and zeros. Lots and lots and lots of ones and zeros. Billions and trillions of ones and zeros. All the computer is a machine that can process ones and zeros. So, since we have different things in the physical world we deal with, we have to encode values into ones and zeros in a way that the computer can understand, right? And that's what the types are. Each thing is a type that has ones and zeros, but they're interpreted differently. Here are the basic data types. We'll talk about 4 of them. There is int, which is short for integer. An integer is a whole number. It can be positive or negative. Okay, int, whole number, positive, negative. You can have a float, which is a floating point number. It has a decimal and can be positive or negative. You can have a char, which is short for character. A character is a single character. Now, by character, I mean pretty much anything that you can type on your keyboard. It's not just a letter. It can also be a digit, like a number. It can be a punctuation mark. It can be a number of things that are not very useful to you, but they're in there as well. One of the things to realize, and I will go over this more, but I'll introduce it now, is that you can have a character that's a digit, like, what's your favorite single digit? 6. You can have the digit 6. It is a character. The way it is encoded is different than the integer number 6. And if you try to use the character as an integer, you will be quite surprised, because I think the integer value of 6 is somewhere between 50 and 90. Like, the encoding is such that the character for a digit is very different than the integer for a digit. Okay? Because when the computer thinks it's a character, it thinks it's a single typable character, not actually a number. All right, and we'll see this more later on. And then finally we have bool, which is a Boolean. What does a Boolean value have? How many values? Yeah. 2 values. Was you raising your hand to answer my question? Here, I'm going to throw more of these things out because I've been eating like the peanut butter cups out of here like crazy. So you have 2 values. A Boolean is yes or no, true or false. Typically we think of it in terms of true and false. These are the very basic data types. There's some others that we will also talk about later, but just to get you into the idea that when you have a bunch of numbers in one of these memory boxes, they have to be interpreted the right way. And the type tells the computer what way to interpret them. Okay? Everybody with me on that? Okay. All right, so let's go back to our thing we were working on then. We were talking about input. Tell me a number. The first thing we had to do was declare the variables that we were going to use. We were going to use one for input and one for the remainder, so we went ahead and declared both of those in our C++ program. This was a step that we did not have to do in our outline version. Okay. Now, the next step we're going to do in our outline version of this algorithm is to tell me a number, or input a number. Here is how you input in C++. Cn, angle bracket, input. The way I like to think of this, so I can remember which way the little arrows go, because you'll see sometimes they go the other way, is data goes from, like, into a little funnel. Like, I think of the little arrow things as a funnel, and data is getting crammed in there, so it's going to flow from Cn into the variable named input. Okay. Cn is the input command. We'll get into more detail about it later. Input is the name of the variable. So, Cn into input, this is the equivalent of the input step on our flowchart, like we were talking about. And when we do Cn angle input, Cn is the C++ word for doing input, and input is the variable name that I chose to hold the input. The variable name does not have to be input. It could be anything we wanted it to be, okay? And when we talk about variable names later, you'll see what your choices are. There are a lot of them. You should make variable name choices that make sense to humans. Why? Yeah. Yep, because someone's going to read your code. A program is not just something that works, it's something that other people can understand. By using the name input there, my hope is that you understand that that variable now holds the input. Okay? Yes, sir? Yes, we initialize the box named input to hold a 0 in it. When somebody puts something in, types something in and uses this, whatever value they type in will overwrite the 0. It will be replaced. So what this really does is this says, okay, get the variable named input, get some numbers or some input from the keyboard, and then stick that number from the keyboard back into input. Okay, so the question is, if we're going to just input into here, why do we have to initially assign something? And the reason is because people range from imperfect to suck, okay? At the very best, people are imperfect, and we all like to think that we are imperfect. And at the worst, people suck, okay? I admit that I'm imperfect. I'm going to screw up and make mistakes. So what I try and do is I try and adopt practices that are continual that I always do so I don't have to think about it, so that one day when I declare a variable that's not getting input put into it, I don't screw up and then end up using some random value that happens to be in there. So it's part of what we call defensive programming, right? People make mistakes. You make mistakes. So if you always adopt a habit of doing something the same way that prevents those mistakes, you come out ahead. Even if it's like, typing 4 more characters when you have to do a variable declaration. Everybody with me on that? How many of you all realize you're imperfect? If you haven't realized it yet, you will through the art of programming, okay? And we'll talk about ways through this that you can work in code that will prevent you from some very common and annoying bugs in your code. All right, everybody with me? Okay. All right, so this is input. Cin is the input operator. Input is the name of the variable, which is the box that holds the data where it goes. All right, good. So we're working through our algorithm. Now it's time to divide a number by 2. This is a calculate step. This is what the operation looks like in C++. Remainder equals input parentheses sign, percent sign 2. Okay. What this says to the computer is we're going to be making remainder equal to something, which means we're going to be storing some value in the box labeled remainder later. But first, we have to figure out what value that is. The way we figure out that value is we go and we get whatever is stored in the box named input. We divide it by 2 and figure out the remainder. Everybody with me on that? Yes, sir. Yes, remainder is already declared as a variable. We declared it before at the same time we did input, right? So we declared it up here. You have to declare a variable before you use it in general. Yes? In C++, the percent sign means give me the remainder. We'll talk about other math operators shortly. If not today, then next week. That is called the mod operator, which is the remainder operator. All right. So, like we said, the computer's a machine. It can get things out of memory. It can do operations. It can put things back. It gets input out of memory. It does this operation, figuring out what the remainder is divided by 2, and it puts the result back in the variable, which is a box in memory, named remainder. Yes, sir? It used to be when we declared remainder 0, it had 0. After this line of code executes, this whatever value is here will overwrite the 0. Right? If you have a box and you have nothing in it, and then later you throw some fish in there, the nothing is gone and it's full of fish. I don't know why that's a good analogy. So, yes, sir. So the question he asked is the same one earlier. Why are we bothering to assign remainder equals 0 when we're just going to overwrite it later? And that's because we as people are imperfect or suck, someplace in between. It is very good practice to keep you from getting into trouble to always initialize your variables, always. And I cannot tell you, I still fall prey to this. I'll be in a hurry and I'll be like, oh, I need a variable, and I'll declare it and I'll forget to initialize it. And then later in my code, I'll use that variable and it will never have been initialized. And it will have some random number in there, and my program will produce utterly random results, and I'll be tearing my hair out trying to figure out why it happened. Okay? Later in the semester, I'll tell you the time that I spent 2 days debugging my master's thesis. I had forgotten one character. I had forgotten just to type one character in there, and it took me 2 days to find the error. When I put the character in, it worked. Yep. Yep. Input is the number, is a variable that holds the number that whatever person runs the program types in. It's a box, right? It's a box labeled input, and there's an integer number stored in there. Initially, there's a 0. Later, somebody types something in there, and that 0 goes away. Whatever they've typed in there is in there. Mm-hmm. You'll see. You'll run this program and you'll see what happens. Okay? What's actually happening is the number that the human types, CN says, hey, ask a human for a number. And whatever number the human types then gets put in input. Because programs would suck if we couldn't do any input, right? Like imagine it would be like the difference between playing a video game and watching YouTube where somebody else had made all the choices for you. So, yes, sir. CN is all right. So you've hit on a flaw of our program, which is CN just reads in numbers. What we haven't done in this program, to keep it short, is output a message to alert the user that we expect them to type something, which is bad practice. However, I'm keeping it simple for our first program. Okay. Good practice would be before we have the CN, we'd have the cout that would say, hey, enter a number. Otherwise, what would happen is we'd run the program and it would just sit there, and the person would be very confused. Why isn't it doing anything? Okay. But just to keep it simple. Everybody good on this idea so far, right? We have a value in the box up here at 0, but then we execute, and after this assignment equal sign is done, there will be a new value in remainder. The old value will be gone. There is no way to get it back. Gone. Yep. Okay. So what we've been saying is calculating the remainder is a calculate step. If we go back and look at our flowchart, right? We had start, stop, input, and output, and calculate, and decision is all the things we could possibly do. This falls under the calculate. All right, the next step, decide, is the remainder 0? We're deciding if the remainder is 0 because we know that even numbers will have a 0 remainder, while odd numbers will have a remainder of 1. So we have to make this decision. The way we make decisions in C++ is we have this statement called if. The statement looks like this, the word if, open parentheses, close parentheses, with something inside that is a Boolean value. It has to be something that will either be true or false. An if statement can only have two decisions, a true decision and a false decision. The thing that we have inside here is remainder equal, 0. Equal. Notice that up here when we assigned remainder, we used 1 equal sign. For the decision, we're using 2. The reason is 1 equal sign is what's known as the assignment operator and will change the value. 2 equal signs is known as the comparison operator and will compare two values. Got it? 1 input, 1 equal sign assigns, 2 equal signs compares. So what we're saying is compare whatever value is in the remainder box to 0. If they are the same, it is true. If they are not the same, it is false. Okay? So look at remainder. If it is the same as 0, then do one thing. Otherwise, else, do the other thing. Everybody good on that? We will see more of what are these called, these Boolean operators or comparison operators as we go along. Okay? You can do more than just comparing if things are equal. You can do not equal, later, greater than, less than, greater than, equal to, less than or equal to, stuff like that. Okay? Who's with me? Who's against me? Okay, just checking. All right, so we've made our decision. Oh, our decision looks like this. Just if we go back to flowchart, right? You have two ways out, true and false. Then we get to output, and we're going to output either odd or even. So let's look at how we do this in C++. C in was input. C out is output. Notice that the angle brackets run the other way. So for C out, we have angle to the left. We say even, ENDL. If it's odd, down here on the else, we see out odd, ENDL. So output is C out, angle left, and then double quotes for whatever stuff you want in there, whatever characters. This ENDL is kind of like hitting the return on a typewriter. That means next time you print something, go to the next line down. Yep. You can take the ENDL out, yeah, and we'll see that a little bit later. When it comes to formatting your output, sometimes you want to use it, sometimes you don't. Most of the time, you'll probably use it. Most of the time, unless you're doing something specific. Yes, sir. Okay, so here's the thing. If you try to put an ENDL on the CN line, the compiler will barf. And by barf, it means when you try to compile it, it will give you lots and lots of lines of output. It'll complain, it'll scream, you'll go, what the heck is going on? You can't use ENDL with input. It only works with output. Okay? Some of you will fall victim to that because it is a common thing that people do. You'll see later, but essentially what it says is it says type this to the screen even, and then move down to the next line on the screen so that next time you type something, it'll be underneath that. Ever seen an old-fashioned typewriter? Have you all ever seen typewriters? Wow. Someday I'm going to ask that question. Nobody's going to have seen it because they're going to be really obsolete. You know when you're typing along a typewriter and you hit a return line and it goes bzzz all the way back to the end? That's what ENDL does. Yes, sir. Do spaces matter? Yes and no. The compiler doesn't care about spaces all the time. We could go through and we could take out all the spaces. We could take out all the returns so it was one giant long line of code, and the compiler would be fine with that. Do we really care what the compiler thinks of your style in your code? No. What do we care about? Humans, right? So when we're typing our code, we want our code to be readable for humans. So yes, it's nice to put spaces in there. It's pretty much the standard because then you can see things. Some people like having really, really dense code so that you can fit more of it on the screen. I just say those people range from imperfect to suck, and they fall somewhere in that range. Okay, so it's nice to have your code formatted well. All right, so here's what we're saying. Cout is how you do output. And that's it. That is our first C++ program. Okay. Everybody happy with your first program? Yeah. Wait. Uh-oh, hang on. I know, sorry, I'm doing this from my remote control. And there. Is that it? Oh, sorry. There we go. Are you trying to copy it? I'll put the code up on Blackboard. All the code we do will be put up on Blackboard. You can also look at the videos. I'm posting the videos online, so, yep. Okay, never mind. Yes, sir. Okay, so the question is, if you make a mistake in your code and you go to the compile and you pick it up, and the compiler picks it up, is it going to give you a message? Yes, it will give you a message. What you're also going to find out is that in many cases, the compiler will guess what you did wrong and try to keep going after that. When it guesses wrong after that, it will print error messages for everything that it got wrong on its guess. So a very small error sometimes might produce tens or hundreds of lines of error messages. I told you day 1 or 2 that the compiler is not very polite, right? That it'll scream at you for simple things. That is why. You'll see. I'm just going to give you a preview. This is the last set of slides I'm probably going to do all semester. After this, I'm just going to fire up stuff and start typing and coding in front of you, and you will see the compiler yell at me all the time, and I'll talk about how to work with it to figure out what the error is and fix it. Yep. Exactly. Mm-hmm. Exactly. So the question is, we have if and we have else. The first one is if it's true, and the else is if it is false. Now I'll just say, give you a preview, we'll talk about this more. You don't have to have the false one if you don't want. You can have just the if without the else, but sometimes you want the else as well. Just depends what you're doing in your algorithm. What is the difference between int input and cn into input? The difference is int input goes into memory and says, give me an empty box. slap the name input on it, and put a 0 inside of there. Okay, that's the variable declaration. Later, our program runs along and it says, hey, input, cin, go to the keyboard, read some numbers that the user is typing, and stick those in the box. And when you stick them in the box, it overwrites whatever value is in there. Remember I said that an algorithm is a series of steps where order matters? Order matters because each one of these things is going to change the values in memory. And once they are overwritten, they are gone. All right? Once they are overwritten. Later in the semester, you might be doing some programming where it matters very much what order things are in because you might need a value, and if you overwrite it first, you can't get it back. Okay? In fact, that will be a problem later in the semester, for sure. Okay, welcome back. So now that we've seen, we've talked about algorithms. Oh, by the way, I meant to ask, how did the homework go? Any questions come out of the homework? Did you all figure out everything okay? Okay. Homework 2 is now posted. You will have 1 week to do it. Homework 2 is how to log into the machine we'll be working on, use the editor, use the compiler, and submit code. It is essentially a dry run for using the tools that you will need to do a program. Okay? And I'm going to actually talk you through the entire assignment today. I will do it in about 4.5 minutes. You can do it in the same amount of time. Except I'm not going to do the submission part for you. I'm just going to show you the other things. So do you remember this diagram? What's this the diagram of? The algorithm for how to work on your projects, right? This is essentially what we're going to be doing the rest of the semester. And what I'm going to do is I'm going to step through how to do this. But here's what you need to know. The compilers differ. If you're using a Mac and you use like Xcode, that is a different compiler than if you're using Visual Studio on your Windows machine. Okay? Different compilers interpret the C++ language standard differently. This means that there are some things that will work on one compiler that do not work on the other. There are a variety of compilers. You all could go out and find probably each one of the rows in this class could find a pretty major compiler they could use for this class, and they all might differ. Because compilers are different, this creates a big headache for grading, right? Because we don't want to have to grade your things on exactly the compiler that you did, because that would not be good for us. So what we're going to do is we're all going to use the same compiler. Yay! Now the downside of this is that the compiler we're using doesn't work on every machine the same, because different operating systems like Windows or iOS or Android or Mac OS all are slightly different. So not only are we going to use the same compiler, guess what we're going to use? The same machine. We are all going to use the same machine. This machine's name is csclass.uis.georgetown.edu. And here is essentially how this is going to work. csclass.us.georgetown.edu is a server. It either sits now in a server farm out in Laurel, Maryland, or it lives in Amazon's web cloud services, wherever Amazon chooses to stick it, probably somewhere on the East Coast of the United States. I don't even know. Okay. You all have accounts on this machine already. You can log in with your net ID and your usual Georgetown password. Okay. Let me show you how this is going to work. So here's going to be, you're going to have your computer, there will be an internet somewhere in there, and there'll be CS class sitting out somewhere else in the world. When it comes time for you to do your work, here's what you're going to do. You're going to connect from your computer to CS class through the internet using a program called Secure Shell. Secure Shell. If you go to the class resource page, I kind of describe this, and when you look at the homework, you'll see I've created videos that talk you through how to use Secure Shell. Okay? So you can download software. How many of you all use Windows machines? Just out of curiosity. Okay, I have actually an old free version of Secure Shell that you can download. It may or may not work with like Windows 8 and higher. If you need help finding Secure Shell that works for your computer, please email me. Okay, I will help you find, there's some new ones, but my videos use kind of the older one. They're all pretty similar. For those of you using a Mac, and how many of you don't have a laptop and use a tablet? Anybody just use iOS or Android? Okay. How many of y'all using Macs? Okay. All right, so you'll all be fine. If you have any problem with your Windows Secure Shell client, let me know, and I will give you an alternative. Okay. All right. So what you're going to do is you're going to connect from your computer to using Secure Shell to CS class. Now the shell is what's known as a command interpreter. It only works based on typing. There is no clicky pointy menus, none of that stuff, only typing. All right? And what it does is Secure Shell takes whatever you type on your computer, and say nano is the name of the program we're going to edit, and clay.cc is the name, and it sends it keystroke by keystroke. Every time you press one key, it sends that key over to the other side. So when you type the N in nano, that one goes first. If you type the A, that one goes second. So you can imagine everything you type getting sent over to the other computer. The computer on the other side puts it back together and runs those commands. And I'm going to give you a demonstration of this pretty soon. Okay? Everybody clear on what we're doing though? You will be using your computer to execute commands that run on another computer on the other side of the internet from where you are. Yes? So, all right. All right, so once we've done the editing, we're going to end up with a file. And here's the file on the computer on the other side, clay.cc. That is my program that I wrote, and it is on the server on the other side of the internet from me. Does that create a problem? Just say yes. Everybody go, yes, that's a problem. And the problem is that you have to submit this file to a different server, either for Blackboard or for something we'll use called Autolab, that will do the grading and is a submission. You have to submit it from your computer, but this file lives over on the other computer. And that's going to be a problem. It's going to be a problem we can solve with a program called FileZilla. Actually, there's a ton of programs we can use for this, but FileZilla is free, it does what we need to, and it works on Mac and PC together. So you use FileZilla to transfer your program over from CS class to your local computer. It's important to understand this. This is confusing at first if you've never done this. The commands you're typing are happening someplace on who knows where. And all the files and stuff are being stored over there. So you have to drag them back. So after you use FileZilla, you will have a copy on your local machine, on your computer that you worked on. You want to do this anyway because you want to keep backups of your code. It's been a long time, but in the past, CS class has been known to crash and lose student assignments. You would be sad if that happened, wouldn't you? No? Nobody would be sad? I would be sad. I'd be sad for you. And then I'd say, I told you so. Okay, so copy everything over. And then finally, once you're done, you're going to upload the code to two places. One place you're going to upload is to Blackboard. Just like you submitted things today, you will submit your code file to Blackboard. The other place you're going to submit it is to another server called Autolab. Autolab is something we are experimenting with this semester for this course. It is a computer that takes your code and automatically runs it and tests it and grades it, at least the functionality portion of it. The idea behind this is that when you write the assignment, I actually write a program that does nothing but runs your program and tests to make sure that it's working correctly. And then the TAs don't have to sit there and like enter 20,000 numbers for each program to make sure they work. Okay? It will give you feedback right away too. That'll be nice for you, so you don't have to wait as long to see how well your grading went. All right? Yes, sir. Yes. It's sort of done on % accuracy. Like your code has to do a certain number of things, and I will write tests for everything that I can think of, and then we will test and make sure that you don't have any errors in your code. You, of course, will test all your code ahead of time, because you cannot, I'm not just going to let you like submit anything until you get a good score. You'll be able to submit your code twice for a grade. Okay? So once, just in case you make a mistake. Yeah? On Autolab, which will do the grading. We'll talk about that more next week. So, okay? All right, so let me show you what we're going to do. And let me also say as an aside that today is the last day that I'm going to use slides. Bye, slides. So, yeah?
So if you've been submitted twice, let's say like you take it and you fix whatever it was, and you somehow, when you submit it the second time, you accidentally made it work.
Oh, man. So the question is, what if you submit once and you make a mistake and the second time your grade is worse? We will take the higher grade because we are kind and beneficent. But we're not going to let you just like do it 1,000 times until you get everything right. You have to learn to test your code yourself. The other thing that we will put up is there'll be a place to submit your code. There'll also be a place to check your code. You'll be able to upload your code and make sure it compiles correctly on the Autolab machine, just to make sure there's no mistakes, because compilers are different and we want to make sure that we're not going to penalize you for a difference in the compiler. You'll be able to run the check on the compiler as many times as you want, but it won't run the full grading suite. So that's the plan, at least. Everybody good? All right, so goodbye slide. All right. Everybody happy to continue? So here's what we're going to do. I'm going to essentially step through everything that you need to do for your assignment. Okay? The first thing I'm going to do is I'm going to connect to the CS class machine. You're going to see how to do this on the Mac. If you look at the homework assignment, there are videos on how to do it on other machines too. Okay? The way I do that is SSH. I have to do clay, whatever my net ID is, at csclass.uis.georgetown.edu. And let me tell you, I cannot tell you how many times I've complained about having to type Georgetown over and over again. If UIS would just let us use gu.edu, do you know how much time the campus would save? Anyway, they own that domain. They just don't use it for anything. It makes me crazy. Okay, so SSH, I get this big scary warning, say this is for legitimate users only. They're going to monitor you. If you do anything bad, they'll come to your house and set you on fire, whatever it says. And I type my password. Anybody see that? Now, notice when I type my password, did little blobs appear or anything? They did not. Don't let that confuse you. When you're using a secure shell, you will not get the little blobs or stars for your password. So you'll think that you're typing and nothing's happening, but it really is working. Okay, so now I'm in on the machine CS class. My configuration is going to be slightly different than what you look at because I'm a computer geek and I have set my configuration up differently. You're welcome to do the same. Yes? I did. So I put in SSH clay at cs-class, and then I hit enter, and then it connected to the remote machine. It asked me for my password, and then I type my password and I hit enter, and then now I'm what is known as the command prompt. Okay, this is the command prompt. Now, I'm going to show you just a few things you can do with the command prompt briefly. You can type ls. That lists the files that are in your directory. My directory has one thing called old. Old is a subdirectory. It's like a folder in there. It's from last time I taught this class. Okay. So now what we need to do is we need to create the file we want, and the file we want is going to be your netid.cc. My netid is clay.cc, and I type nano. Nano is the editor. Do you remember back to that diagram where we do things? We edit and then we compile. Nano is the editor. So here I am in the editor. There are a variety of editors you can choose. Okay? Nano is the simplest one. It's fine for what you're doing. If during the semester you get frustrated because Nano is not powerful enough for you, then it would be good to learn a better editor. But this one's fine to start with. Absolutely fine to start with. There's so much to learn that we don't want to overwhelm you. Starting with something simple is fine, right? So, Nano. Nano, once you're there, you can just start typing stuff. So, I do pound include iostream using namespace standard int main, open close parentheses, brackets. I normally just go ahead and put the start and stop on at the same time. Okay. All right, so I have essentially the outline of a program. Anybody happen to call up the assignment yet to see what your program has to do? Yeah? That's all it has to do is output, I have done my homework. That is the whole algorithm to output, I have done my homework. What is the thing we use for output? Cout. I have done my homework. That's it. That is the whole assignment. Is that a pretty difficult program to write? No, it's not. Okay, so here we are in the editor. We have created our whole program that we need to create. What we need to do now is to save it, okay? Now, what Nano does is it gives you, down at the bottom, a little tiny menu of stuff so you have some idea of what's going on, okay? It's not always very clear. What this little caret means before each letter actually means hold the control key. Hold the control key. So, Control G is get help, Control X is exit, Control O is write out, which I don't know why they just didn't call it save, but here's what we're going to do. I'm going to hold Control, I'll hit W. That didn't go very well. Hang on a second. Oh, because, anyway, Nano is Control O for output. I'm used to another editor called Emacs. Okay, so Control O, file name to write, clay.cc. I hit enter, and it says it wrote 9 lines. Are there about 9 lines in here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, well, I miscounted one at the top. There's about 9 lines in there. So it got most of the stuff. Okay. So now we have edited our program. What comes next? Compiling. So here's how we get to the compiler. We exit. Now if I type ls again, we'll see that not only is there that old folder, but now there is a file there called clay.cc. Everybody see that? What is the editor we're using? Anybody know? The editor we're using is called G++. So you type G++, you type the name of the program you want to edit. I'm sorry, the name of the program you would like to compile, and then you hit enter. Didn't print anything. When it doesn't print anything, that's good news. The compiler only gives you bad news. So if it doesn't say anything, that's good news. If I type ls again, you'll see that there's something there now that wasn't there before called a.out. And in my thing, it has a star after it. A star means that it's a program. I can run this now by typing /. You have to do that for magical reasons that I'm not going to explain to you. And then type a.out, and it says, I have done my homework. Here's what I'm going to do. I'm going to clear the screen and do it over again because then it appears at the top where you can see it. Is that a little better? So we edited the program, we compiled it, we ran it, it all worked very well, right? All right, everybody with me so far? Yeah? Uh-huh. Yep. You have to use your net ID, yes, unless your net ID happens to be Clay, which would be quite confusing between the two of us. So, yeah. That's what ran the program. I'm going to show you something. We'll show it in just a second. Yeah. You generally have to type your net ID. Yes, just type your net ID and @. That is the safe thing to do. You don't always have to do it. I don't want to go into when you don't have to do it though. So just go ahead and do it. Yeah. Yep. So I'll show you a couple things. Everybody good with this? I'm going to show you a couple things and answer a few questions, okay, that came up from before. But everybody's sort of good with what we've done here? All right, I'm going to go edit the code again, nano clay.cc. And the first thing I'm going to do is I'm going to take out this ENDL, since there seem to be a lot of questions about what happens if that's not there. We don't need it, okay? So let me do Control O to output it. Let me exit. I'm pushing the up and down arrow, by the way. It keeps track of what commands you've typed in the past. So if you do up and down, you don't have to type everything over. It kind of remembers, okay? And I will compile it again. Well, that worked. Now, the compiler produces, when it compiles this program, clay.cc, and the output, the executable, the computer can understand is this a.out, which is a horrible name, and I will show you shortly how to fix that, okay? But let's run our program again. Now, you all remember, what was the change I made between this program and the last one? I only took out the ENDL, the endl. And so when I run it now, it says, I have done my homework, but look, our prompt that gives us the command is right there. It did not put that ENDL out, which says next time you type, start on the line down. It just types whatever comes right after that. So does that kind of answer the question about ENDL? It's much better with the ENDL. How many of y'all like the ENDL better? Me too. Yes, sir, question? Are these instructions online? They're in the textbook. They'll be in the video. But yeah, I've tried to create videos that show you how to do this. Okay? So this kind of sucks. I like having the NDL. Let's put that back in. I compiled again instead of editing, sorry. So we'll go put that back in. By the way, this is your fate for the rest of the semester, is watching me type stuff on the computer. Just so you know. Okay. It's awesome. And if you think you have a fear of public speaking, you should try public coding, because it's insane. You have to talk and type and compile and think about your program all at once. And when I come out of this class, I'm exhausted, particularly later in the semester. Okay, not that you care. All right, so G++. I have this C alias to clear my screen. It won't work for you, but run this again. And now we can see with the ENDL, the end line there, it's much nicer, right? All right, let's do another thing. I was asked what happens when you make a error in your program, right? And the compiler yells at you. So let's go in and make a purposeful error in the program. The most common error is to forget a semicolon. So let's take that semicolon out. I have no idea what that's telling me. Okay. The most common error is to leave the semicolon out. So let's do that. I'm going to write this program out. I'm going to exit. I'm going to compile it again. Oh. What does this say? In function, int main, clay.cc:8. This is the line number where it found the error. Error, expected, semicolon before return. That's actually a reasonably polite message. I've been teaching this course for like as long as some of you have been conscious of your own existence, and the compiler has gotten a lot better over the years. It's not as rude as it used to be. Okay, that's actually a pretty helpful message. So here's what we'll do. We will go back to editing. This is nano.cc. And line 8. Okay, how do I find line 8? I can just push down the arrow a number of times till I get there. But later, when your code is like 500 lines long, that's going to suck. So I'm going to show you. What we have here is we have, see this right here? Control W, where is? If we hit Control W, it will bring up a little editor. And then it brings me other choices. And if I hit Control T right down there, it will say go to line. So I'll go Control T. I'll hit line 8. Bam, and I'm at line 8. And it said it was expecting a semicolon right there. So what that means is I forgot the semicolon on the line above. I add that. I write it out. I exit the program. And when I compile, now it works again. Yes, sir. Control X. Okay, I'm going to show you something to make your workflow a little smoother in just a second. Okay? Trying to keep it simple. Am I keeping it simple enough? How many of y'all feel a little bit bored sometimes? Ooh, okay, that's bad. I was hoping a few of you would be bored. How many of you were actually bored and didn't raise your hand? Come on, Java programmers. I know you're out there. All right. All right, everybody good on this so far? So let's take a quick look here. If we ls, we can see we have the program we wrote, clay.cc. We have this a.out. That's just not a very useful name, is it? So there's two ways we can fix it. One is when we're at the command prompt here, we can say move a.out. If I can only type a period, that would work. Okay, a.out. And we could move it to something else. MV is short for move, and it says move the program a.out, and we'll just call it prog for program. And if we do ls, we'll see now there's this thing program there. Okay. That's what MV does, move. There is another thing you can do as well. However, this is dangerous, okay? It's dangerous. It's bad. It's like not even a little bit dangerous. It's super dangerous. And I will show you. When you compile your code, you can do this. You can say G++ clay.cc. This means compile the program clay.cc. And if you put a -o, that means when you're done compiling, put it into a different file name. And so I'll just put it in the file clay. Now, let me ls, and you can see now there's the program clay.cc. There's also the program clay. Okay. What do you think could possibly go wrong? Yes, sir. Well, that's fine. This put it into a file that doesn't exist. It created the file. So that turns out to be okay. What's dangerous? Okay, so you can get confused. That is also a minor danger. Let me show you the mortal danger, the soul terrifying, horrible, horrible danger that will happen. All right, so here's what happens. I will say g++ clay.cc -o. Hang on a second. Let me get rid of the old clay program, okay? rm gets rid of things. So I remove clay. All right, so I do g++ clay.cc -o. I hit C and I hit tab. I hit C and I hit tab. The shell tries to be useful for you, so you don't have to type everything. If you type a couple letters and hit tab, it will finish up for you. Okay? It finished up. What this command line is saying, compile the file, clay.cc, and when you are done, put the executable file in the file clay.cc. What happens when we do that? I'm going to do it right now so you'll find out, okay? What's going to happen? All right, great. Now, we go, oh, let's edit clay.cc. Ah! What happened? Where did our program go? Pardon? Yes. What ended up happening is we took our human readable source code and overwrote it with the computer executable code. How many of you all can read and edit this? You just can't, right? And what's going to happen is if this happens, it's going to happen at like, let's see, the program's due on Wednesday. It's going to happen like Wednesday morning at around 4:37 a.m. when you've pulled an all-nighter. And you're going to send me an email and you're going to be like, I overwrote it. It's horrible. I'm going to be like, yeah, that sucks. Too bad for you. Okay? You cannot go back. There is no going back. That program, clay.cc, is gone, and all we have now is the executable. So you can use the -o flag. Just be very, very careful. Typically, this happens even with my warning like this. It happens once a semester. So you all have 5 projects to do. There's 50 of you. So I would say there's a 1 in 250 chance that each time you do this, something's going to go wrong. Of course, I'm not very good at statistics, so I don't even know what that means. All right. Everybody kind of good on this? Yeah? Yep. Yep. Unless you had made backups. So let me get out of here. I'll just get rid of the stuff. So I will show you what we can do is, I should have made a copy of this before I messed it up, so I have to type it over again now. Okay, so now we should be good, and if I compile it again, we'll make sure it's working. I almost ran that command again. That would have sucked. Okay, so we're back where we are. Okay, so here I am. I have clay.cc. What you might choose to do as you're working along is like every so often, use CP, which is copy clay.cc. And what I like to do is I do clay.cc 11.1155 or something like that, right? So I put like a little timestamp on there. The real way to do a timestamp, 2017, 09, 13, 11:55. Okay? And now if I do an ls, I will have the one I'm working on, right? But I'll have a backup. So you might choose to make some backups as you go along. And that way, if you screw up and overwrite it or lose it or something, you will have not so far to go back. So CP is copy. All right, everybody good on all that stuff? How you all feeling? No, because I went back. So cat will output a file to the screen, and so if I cat clay.cc, you'll see I went back and retyped the program. And if I cat clay.cc with this timestamp, you can see I have the same program there. So. All right, so this working in this environment with typing stuff is a little bit confusing at first, right? It takes a little getting used to, but it is incredibly powerful. Like later, I will start showing you. Actually, this is probably almost all I'll ever do. But if you ask me nicely and we have some time, I will show you the incredibly powerful stuff you can do by typing commands on the command line. Okay, way better than a GUI if you're a hardcore computer geek. Okay. All right, everybody think they're good on this? Think you can log into the machine now and type your code and stuff? And then FileZilla, I don't have a copy on my computer right now, but you can figure that out. If you get stuck, you can ask me or the TAs for help. It's pretty straightforward. That's the whole homework. Questions on the homework? Do you like that I'm just giving you all the answers? Isn't that awesome? It's the last time, so as a warning. All right, any questions? So what I'm going to do is I will, all the code that I do in the class by here, I will make available. I'll either leave it on CS class where you can get it, or I'll upload it to Blackboard or something like that. Okay, so you will be able to get all the code I do in class. All right, who needs a 1-minute break? And then we'll start getting into coding. And what we're going to do is I'm going to start developing programs. I'm going to show you new features. We'll go into more detail, and we'll just keep building code on the screen like this the rest of the semester. All right, ready? 1 minute, break in place, go. Oh, shoot. All right, that's about a minute. Plus, there's something else I wanted to show you, okay? So here I was editing away my code, right? And it was really annoying because every time I edited my code, I had to stop and get out of that program to compile. And that's annoying. So let me show you how to get around that, okay? So here I am. I'm editing my code. What I'm going to do is I'm going to go up to Terminal, and I'm going to get a new window. And now I have 2 windows. This one's a little bit smaller, okay? And I'm going to SSH just the same way I did before. And now I have 2 windows going. And what I'm going to do is I'm going to make all my edits over here, right? So let's just take this out. And in the other window, I'm going to do my compiling. So I do my compiling over here. It doesn't work. I switch back to this one and say, oh, I need to put a semicolon in. And then I output it, write it out. And then I go back to this window, and I compile, and it works. And then I can do my testing over here. So I can switch back and forth between the 2 windows. I use one window that's logged in for my editor, one for my compiling and testing, and then I don't have to switch out of the program all the time. Does that make sense? Yep. Yes, you have to output it in this window before you can test it, because otherwise it's not written to disk. When this thing runs, it reads the compiled file off of the disk. So it'll be a lot faster that way. Yeah. Here, I will exit out and I'll show you again. So I was using the Mac, and so what I did is I went to Shell, new window with same settings, just like that. And then I did the same SSH, my net ID at csclass.uis.georgetown.edu. And then I had to type my password again and stuff. Yeah. So terminal is under the utilities folder. It's like applications, utilities, terminal. If you look at the video on the homework page, it'll show you how to get in there. So you can do a new shell. You can also do a new tab. Some people have like tabs, and they switch back and forth between tabs in the same window. I don't like that. Normally I work with a big enough monitor that I can have 2 windows open side by side. So my laptop, I can't do that very much. But okay, so that can make your life easier so you don't have to switch back and forth. Thumbs up? Okay, good. Well, here's what I'm going to do. Most of the time in this class, I am not going to work on CS class. I'm just going to work on my machine right here, which is named horror. And when I edit code, I'm going to use this editor here that's called Emacs. Emacs is a more powerful editor. If over the course of the semester you'd like to learn Emacs, a lot of the control keys in Nano are similar. But Emacs is a very large and powerful editor. If Nano is the equivalent of like a battery drill, then Emacs is the equivalent of a 48-inch chainsaw powered by a snowmobile engine. Okay, it can like cut through trees in an instant, and you can also cut off your legs in about half a second. So there's a learning curve, but it's very powerful. I like it. If you're a computer scientist, then the other editor people like to use a lot is something called Vim. And Emacs versus VI or Vim is like the leading religious debate in computer science. And people who use Vim are heretics and should be burned at the stake. Just to make that clear. And you should tell Professor Malouf in our department that if you meet him, okay? So he knows where I stand on this issue. All right, so I'm going to use Emacs, and Emacs will kind of be the editor. It'll look a little different. Same thing, just different idea. The first thing I want to talk about, though, before we start looking at code stuff, is an issue of notation. It's an issue of notation, okay? I'm going to use a particular notation to describe the language to you. And the notation that I'm going to use is something that's called the Bacchus Noir form. This will not be on the test. Okay, Bacchus Noir form. What this is this just a notation that we can use? By the way, is the text big enough for everybody to see? We good? Okay. The idea of Bacchus Noir form is it's just a notation you can use to describe language. And here's how it works. Anything between angle brackets is a variable. And I'll show you some examples of this in a second. Anything else is what's called a terminal. And a terminal is a final value. Okay. So let me give you an example of this. Let me say we can describe something that's called a first name. And a first name is a variable, means it can take on some other values. And we use this notation, which is : equals this thing, : equals is defined as, means is defined as. So the first name is defined as an uppercase letter, followed by lowercase letters, it's a little bit bigger, followed by a plus sign. The plus sign means one or more of these. If you have a star, that means 0 or more. Okay? Don't get confused. This isn't on the test. I just want you to be familiar with it because as I describe things in the language, I'm going to use this. So we can say as first name is a variable. It's defined as a variable named uppercase letters, followed by a variable named lowercase letters, and there's going to be one or more lowercase letters. So now we have to define with the terminal what uppercase letters, and we define those as, what do you think uppercase letters are? A to Z. We can define the lowercase letters as what? A all the way through Z. So what this is telling us is we have a formula now that can give us a first name. The first name is defined as an uppercase letter, just one, and lowercase letters means one or more. So we can say, okay, uppercase letters we can replace with something from this range A to Z. Naturally, if we were going to do this, we would all choose uppercase C, right? That's my name. And then some lowercase letters, one or more because of the plus sign. And you can choose any one or more of A to Z. So obviously we would choose L, A, and Y, and we would make the first name Clay. Everybody with me on this? So this is kind of all you need to know for this notation. The other thing that doesn't show up, that will show up later, is we will use square brackets. And things inside square brackets are optional. So what we might choose is we might choose to make something that is a name, and the name is defined as a first name and optionally a last name. And then we just have to come up with a rule for last name. Last name's pretty much the same as first name in our case. So now we have a formula for last names. Let me make sure I write this in the right spot. Okay. Do you all understand where I'm going with this? Not going to be on the test, just a notation. So we're familiar with the notation. Yeah? Yes? Is there an extra L? Oh man, you all are worse than the compiler. All right. Yes, there is an extra L. Where is the extra L? Help me. Here? Up. Oh, lower case letters. Yeah, see? That's what happens when I'm thinking the name Clay while I'm typing, right? So my innermost thought processes leak out onto the screen. It's terrifying. Okay, so good. So we have an add program. All right, so let's see. That's our initial thing. So let me show you one thing. So here's what we're going to do. We're going to do a program called comments.cc. Every program has the same thing, #include IOStream using namespace standard int main. Okay, I'm writing the program that does what? Yep, it does nothing. It just starts and stops. It does no useful work. I'm going to show you the first thing that is useful to know. In C++, we have what are called comments. Anybody want to tell me what a comment is? Yep. It's basically something that when you look at the source code, it's a note for humans. Sorry. I just have way too much candy here. Just wake over there. Oh, sorry, that was a bad throw. Okay. So here's how you do a comment in C++. Double slash at the beginning of line. This is a comment. If I do something like cout, the computer sucks. If I compile this program, what's going to happen? Nothing. And the reason is that when the compiler goes through, it looks with anything that has that double slash in the front, and it ignores it. The compiler doesn't care about anything that has that double slash in the front. That is only a message for people, not for humans. The idea of comments is we want our programs to be understandable by people. We can leave notes for people that the compiler doesn't read. Okay. Even if it's a valid line of code like that, it will be ignored. Yep. Yes, this just goes for that single line. If I try and type something like this, if I say this is a comment, but this is not, what will happen is when I try to run, if I try to compile this, which I will, let me just get to the right directory where I put everything. Okay, so here I have a whole bunch of stuff in here. I'll clean this up later, but if I g++ comments.cc, it will throw an error. It goes, wait a minute, I have no idea what you're talking about by but, because that is not a C++ word. See, so it tried to read this as a comment. If I put the comment slash in front of it, and then I go and compile it again, it compiled fine, right? Oops. Oh, sorry. All right, and then if I run it, what is this program going to do when I run it? Nothing, and this is why I have to put the dot slash in front of it. Otherwise, it can't find it. So the comment is just for other people who look at your code to know what's there. Okay, so there's one other way to do a comment. All right, well, let me tell you before I describe this. Okay, so this language, C++, is a language that is derived from an earlier computer language. Anybody know what the earlier computer language was? Yep. C. C is derived from C++. Because of that, some of the things that show up in C++ are not actually part of C++. They are part of C. This is slightly confusing. Okay? Slightly confusing. But you all know how to cope with this. We all speak English. Is English a language that was created entirely out of whole cloth and no words existed before? No, absolutely not, right? It's a conglomeration of different languages, so we're used to the fact that sometimes we have things that are irregular or weird, right? Things come from Latin, from German, from French, probably a whole bunch of other languages that I'm not even thinking about because I'm not that kind of professor, right? So we have irregular things. So this, what I'm showing you right here, is what's a C++ style comment. Let me show you the other way. This is a C style comment. You do slash star, star slash, and anything in between these two things is a comment. In fact, if I keep adding lines, they are comments too. Okay, so a C style comment has 2 lines at the front. A C++ style comment has the 2 slashes at the front. A C style comment starts with the slash star and ends with the star slash. Very commonly, if people are spanning multiple lines with comments, they will put an additional star in each line just so that it makes it clear that it's a comment all the way through. But that's not necessary. Okay. All right. Yeah? Both of those would work, yeah. For the most part, I recommend you use C++ style comments because we're learning C++. Where C-style comments come in useful is if you're working in your code and you have some scaffolding code that you want to have disappear, you can just comment it out by adding that above and below, and that code will disappear as far as the compiler goes. So it's useful later. All right. One of the things you'll have to do is when you submit code is you will have to put like a little honor pledge at the top that's a comment saying that you haven't gotten help, or if you have gotten help, where it came from. All right. Go off, do your homework, have a good weekend.